Hi students, this is Mr. Liao. In this lesson, we are going to learn the last two key features of functions. The first one is end behavior. Here's a definition. End behavior, how a graph acts or behaves on either side. When we say either side, it actually talks about when we look on the left side or the right side of a graph. For this year, we will specifically learn about what happens when a graph goes all the way to the left and all the way to the right. And when we say all the way to the left, well, that's going to be negative infinity, and all the way to the right is going to be infinity. And that's why the notation as x, the arrow is read as approaches. So as x approaches negative infinity, f of x approaches something. Or as x approaches infinity, f of x approaches something. So that's how we actually read these. These are going to be the notation we use this year. Next year, you're going to actually update them. You're actually going to be using limit notation, which will look slightly different, but they actually mean the same thing. So now let's actually understand a bit more about the notation. As x approaches negative infinity, that means you're looking on the left side of the equation, or left end of the graph. And typically, x, we have learned before, x is called the independent variable. That's why we look at the x first, and then the f of x, or in other words, the y, is going to be dependent variable. That depends on where we are looking for the x. So that means for our graph, we're going to look at the left side first. I'm going to see what is happening with the y. Afterwards, we're going to look on the right end and then also see what is happening with the y. That's end behavior. Now let's have a look at some examples. Number one. As x approaches negative infinity, we always have to start with them this way. So this means we're looking at the left end. So this is our graph. The left end is right here. That's the left end. If I ask you to describe that arrow, where the arrow is going, just using plain English, you could say is going up left, which means at the same time as going left, it's also going up. So this left end, the x approaches negative infinity, already took care of the going left. So I now need to describe what is happening with the y value, which in this case is going up and is going up forever, which means the y is going to infinity. Next, as x approaches infinity, that means I'm looking for the right end, which is right here. If I ask you to describe that arrow, is actually going down right. So it's not just going one direction because this is a two-dimensional graph. So it's going down right. The right is already taken care of by the x is approaching infinity because that's actually going to the left, going to the right. Now I need to look for where y is going vertically, and it's going down. When it's going down forever, that means going to negative infinity. Next, f of 0. Typically, we have f of x. So now you see x is being replaced by 0. So this actually means when x equals 0, what is my y? So let's look for x equals 0. This is my x equals 0 on the graph is this point. The y value for that point is 1. So f of 0 equals 1. That's example 1. Example 2. Same idea. First, this negative infinity means I'm looking at the left end. My left end is going down left. So besides going left is also going down. So for my y value, it going down forever means going to negative infinity. For this year, again, we're only looking at going forever to the left and forever to the right. So we're looking just at the negative infinity and positive infinity. So we just finished the left end. Let's look at the right end because the second part is as x approaches infinity. So we're going to look at the right end. Well, the issue is for this one, it's not an arrow. It's actually a point. So my graph actually stops right there, which means the question is, does my graph even going forever to the right? The answer is no, because the graph stops right there, and I'm looking for when it actually goes on forever to the right. My graph doesn't do that, which means I don't know what's happening at infinity, so the answer is not applicable, NA. And then f of 8. f of 8 means, again, when x equals 8, what is happening with my y? So when x is 8, which is right here, this is the point I'm looking at. The y value for that point is at 10. So f of 8 is 10. Moving on, example 3 and 4. So this time you're going to practice writing the notation as x approaches negative infinity, comma, f of x approaches, or as x approaches infinity, comma, f of x approaches. So here they are. The first one, you're looking at the left end. It has to go on forever on the left end. Well, this is my left end, but it's a dot. It's not an arrow, which means it doesn't go on forever to the left. So the end behavior is not applicable. And the right end is when we look at positive infinity. Well, same thing. On the right end, this is what's happening with my graph is a dot. So it doesn't go on forever to the right. So the end behavior is also an A. Next, f of -1, which again means when x equals -1, what is happening with my y? -1 is right here. This is the point on the graph. The y value for that point is at 2. So f of -1 is 2. Example 4, practice writing the notation again. As x approaches negative infinity, f of x approaches. So there you go. This again is looking at the left end. So my left end is right here. That is going to the edge of the graph. So that basically means there is an arrow. And when you want to describe that arrow, it's still going up, even though it's going left little by little. But it's still going left. So it's actually going up left, which means when it's going left, it's also going up forever to infinity. The right end in this case is actually the same thing. When it's going to the right, it's also going up forever. So it's going to infinity. f of -2, when x is -2, which is right here, well, it's only going up by this much. The value right there is at 1. So that's f of -2 equals 1. Next, example 5 and 6. So 5 and 6, same thing. You're going to practice writing the notation. So 5, as x approaches negative infinity, again, just means I'm looking at the left end. So this is my left end. It's going to the left and it's going down. However, it's not going down forever. So I know it's going to the left, but my y value is not going down forever. If you remember what we have learned, well, let me rephrase. It's going down forever, but it's not going to negative infinity because, well, we have already talked about it. This part is almost going flat, but it's not even touching the x-axis. So that means the smallest y value that we could potentially kind of get to is this x-axis, which means the y value is approaching 0. On the right end, well, again, infinity means I'm looking at the right end. So this does go up and right. So when it's going to the right, it's also going up forever to infinity. As for f of 2, this is the x equals 2. So when x equals 2, my y value is at 4. So f of 2 equals 4. Example 6. When x goes to negative infinity, that again means I'm looking at the left end, which is right here. It's going left, but it's also going up forever. So it's going to, f of x is going to infinity. It's approaching infinity. As for the right end, it does actually go to infinity for the horizontal for going to the right, but it's the same thing as 5. The y value go down forever, but it doesn't go to negative infinity. It's actually approaching this line right here, which is at 3. So f of x is approaching 3. F of -1, the value is at 5. So f of -1 is 5. Next, 7 and 8. 7 is actually the same as 7 is the same as example 1. Left end right here is going left and down, so it's going to negative infinity on the left end. The other side going up right, so when it's going to the right, it's also going up to infinity. As for f of 0, the value is exactly at -1, so f of 0 is -1. Example 8. As x approaches negative infinity, this is similar to example 2. The left hand, well, it's a dot, so it doesn't actually go on forever, so it's going to not applicable. When x approaches infinity, which means you're looking at the right end, that is going up, right. So besides going to the right, is also going up. Going up is going to infinity. F of -5 is actually giving us a y value of exactly 5. So f of -5 equals 5. That is example 8. Then the last thing we are going to do is to evaluate different functions. Start simple. Number 9. Whenever we are evaluating we are replacing things. So typically you see it's g of x, but now it's asking for g of 2, which means 2 is replacing the x. So it's almost like the substitution method that we have learned. We are doing substitution. So g of 2 is 2 times 2 plus 5, which is 9. That's example 9. Example 10. That means x is being replaced by -3. So it's h of -3 equals, but something that you have to be very careful, which is very important, because x is -3, and it's -3 being squared, not just the 3. So you have to put -3 inside parentheses to square it. If you just write -3 squared, the square is only on the 3, not on the negative sign. But you actually have to include that negative sign with the 3. That's why you put it inside parentheses. -1. And when you type in your calculator, you also need to type in the parentheses. So this is actually going to give you a positive 9 minus 1, which is 8. Number 11, absolute value. So f of, well, this time is -5. So we're replacing the x with -5. And if you forgot about that symbol means absolute value. Absolute value of -5. In other words, how far away is -5 from 0 on a number line? And the quick calculation is just absolute value symbol changes all the negative values into positive. And when we say all the negative value, it means after calculation, this number, when there's only one number left in the absolute value, is going to change that number to be a positive and then get rid of the absolute value symbol. So the absolute value of -5 is actually 5 and plus 4, which is 9. Next, example 12. h of -1 equals, was -1 plus 3, then -7. You do need to do the calculation first inside the absolute value. That is going to be the absolute value of 2 minus 7. Well, it's already a positive number. How far away is 2 from 0? It is just 2. 2 minus 7 equals -5. Now let's actually say we got a question that is 5 and then x plus 3 inside. Well, it's going to be the same thing, h of -1. So we're going to need to ignore that 5 because the absolute value symbol doesn't function like parentheses. You can't distribute. You have to calculate exactly what is inside the absolute value and then multiply the answer with 5. So in this case, -1 plus 3, and then -7. I'm going to calculate the inside, so it's 5 and then still a 2 minus 7. And then eventually we can actually take out the 2 outside the absolute value, so it's 5 times 2 minus 7, which is going to give us 10 minus 7, which is 3. Next, example 13. So a is being replaced as 1/5, so it's -5 4 times, that's multiplied with a, so it's times 1/5 minus 1. -5 divided by 4 times 1 divided by 5. This is how you can type in your calculator. It's -5 divided by 4. You want preferably put it inside parentheses and then multiply and put it inside parentheses for the second fraction. That's how you would actually type into your calculator. It's going to give you a -1/4 minus 1, which is -5/4 as a fraction. Number 14, f of 0 is 3 times 0 plus 1. The x is being replaced by the 0 on the top and by the 0 on the bottom. So 0 minus 1 on the bottom. Calculate the top. 3 times 0 is a 0, plus 1 is a 1. 0 minus 1 is the -1. 1 over -1 simplifies to be -1. And that is example 14. And that is everything for key features of functions C. Thank you.